Hi there, welcome back to the whichermath channel, and we're taking a second go at this standard, the 7th grade standard for factoring and expanding linear expressions. Okay, in a previous video, just to recap, just kind of showed you with this graphic organizer how to start off with just your basic simplified or expanded expression, how to break it down based on coming up with common factors, and how that can show several different ways to write the exact same expression. And then by showing how to distribute each factor through the parentheses, yet we come up with more ways of showing the same expression. And then finally, when completing the operations shown here with the parentheses, doing the multiplication, they all end up going back to being the same thing that it was. Okay? So, and based on that organizer, you can see I have 7 different ways of writing the same expression. And part of the standard is being able to recognize and create equivalent expressions, meaning they're really the same thing, just organized in different ways. Now, for those of you that are maybe kind of like me and more of a visual learner, that all maybe makes sense on paper, but if you have to then go do it yourself, maybe it doesn't quite make so much sense. So this video we're going to use manipulatives. These are things that I can touch and move around and demonstrate with. Okay, now in class, I know you're not in my class, or maybe you are, but we use these and we call them X and 1. We went through a big process of learning why to name them that, and there's a reason behind it, but we're not going to go into that right now. Okay, and you might not have these wherever you are, but hopefully by watching the video and seeing how I can move these around and reorganize them, you could certainly draw pictures on your paper, and that will serve the same function of giving you a visual way of organizing these things. Okay, so let's start with what I have here, which is, let's see, over here I have 2 1s. Oh, there's another 1. Here's an X. I'm just kind of writing down everything I have here. Here's another X. I see 3 1s down here. I'm going to put those together. I got 2 1s right there. And I've got 2 X's over there. Okay, so I've just named everything I have. That's an expression. It hasn't been simplified in any way. It's pretty rough. So first thing I want to do is combine like terms. We talked about this before. That simply means put the same things together. Okay? Put together, that's combine. Same, that's a synonym for like. Terms are the things, in this case, the X's and the 1s, but you might have other things in your expressions. Sometimes in class we use technical talk and we call it stuff. But anyway, we need to put these things together so we can really see what we have. So let's do that. I'm going to put all the X's together and all the 1s together. So I combined like terms. I put the same things together. So now I can rewrite an equivalent expression. So instead of having this big mess here, and you could imagine if I had to solve a problem with that, it would be pretty complicated. Now I can just say, oh, look, I have 4 of those, and I have 8 of those. Nice. That is actually what's called simplified form. Okay, that means there's no parentheses, and I've combined all the like terms. All the same stuff is together. I don't have a bunch of extra, garbage or duplicates hanging out there. So I've combined like terms, and there are no parentheses, and they're in order of power. Order of power simply means, in order of exponents. So I would have my 3's, my 2's, my 1's, and my numbers. In this case, I just have my 1's and my numbers, my first power and my numbers. Okay? So we just keep them in order. That's called simplified form. Let's organize these another way. Okay? You could see that, hey, I could shove them all back together here, and I could break them into 4 equal pieces like that, right? Once again, I didn't take anything out of the picture. I did not add anything to the picture. I have all the same stuff. Okay? Same stuff means equivalent expressions. Okay, if nothing's been added or taken away, it's equivalent. Same stuff, but now it's organized in a new way. Okay? And the new way is I've got groups of x plus 2, right? This is x, as we talked about, and there's 1, 2. So that's what's in the group. And how many groups do I have? 4 groups. How many groups? That's another way of saying what's the common factor. Okay? Common factor. Okay? So there is another equivalent expression. So far I have 3. We have this big mess we started with, which is the same as 4x plus 8, which is the same as 4 groups of x plus 2. Can we organize these in another way? Well, I could take each of these groups and put them together like that, can't I? Yes, I can. So now, what is in each group? Each group has 2x plus 4 in it, right? 2 x's, 4 1's. How many groups? That's where we create the parentheses. We have 2 groups of 2x plus 4. Okay? Is there any other way to organize this? Well, if we take this right here and split it up that way, wow, now I have 4 different things. I don't have 4 equal groups, but I've got two of those, and I've got 2 of those. Right, that's up top here. 2 x's and 2 2's. And I've got 2 more x's, and I've got 2 more 2's. That's just another way of reorganizing them. I've got, let's see, 2 groups of 2x and 2 groups of 4. I know it's getting messy. See, there's a group of 2x, there's another group. So that's where this came from. 2 groups of 2x. Over here I've got 2 groups of 4. And this is showing distribution. Okay. Wow, let's look at what we have here. I think that's going to bring this video to a close, and it serves my purpose of, see, we started with a bunch of random things all scattered around, and we just kind of named what we had in the order it came up. Then we organized, hey, I have 4 of those, and I have 8 of those. Every time you hear the word of, you're thinking multiply. Okay, I have 4 of those and 8 of those. Okay, then we organized again. I put them back together. We found equal groups. Each group had x plus 2 in it, right? X plus 2. And we had 4 groups. So there's another equivalent expression. Then we could also create 2 equal groups. Each group had 2x plus 4 in it. There's 2x plus 4. There were 2 equal groups. There's another equivalent expression. Okay? And we can show the distribution. We can continue to show this in many different ways. But the whole point of this video is there are really infinite ways to show equivalent expressions. We need to be able to combine like terms, and sometimes having a visual aid is a nice, easy way to help you see how things can be reorganized in lots of different ways. Thanks for watching. I hope that helps you with equivalent expressions.